All right, so we're going to go ahead and cover circuit theory, at least, the general grasp and understanding of how it all works. So to get started, I'm just going to go ahead and just draw a basic electrical circuit. This is probably something that you've made at least maybe once in your lifetime, or if not, you've at least seen something like this. So say we have some sort of battery. This is not actually how you draw a battery in a schematic. You would actually draw something like this with a long line, then a short line, then a long line, and then a short line. But the idea is you connect one of the top ends with a wire to something. I'm going to go ahead and just say a light bulb. We'll work with the light bulb here. And there's some sort of filament, so a typical filament light bulb. And then the other wire will connect to the other part of the light bulb, and it will turn back to the battery. And once that happens, electrons are going to flow in one direction, and once it goes to the light bulb is going to turn on. And that's pretty much it. So the idea inherently of a circuit really is just something that just repeats over and over again. And it starts from it effectively starts from one area and then loops around and starts from there all over again. So in this instance, the idea is that electrons will flow in this direction. Actually, this is the incorrect flow of electrons, but we'll discuss later why this is the typical way you would draw the arrows in this direction of current flow. But the idea is that there's going to be these charges that flow in this particular direction, and then with this particular movement of charges, the light bulb will turn on. So in the context of circuits as an engineer, it's not important to understand circuits just in the case of an electrical sense. But the idea of having it as a theory is that it extends to many different disciplines. Any sort of system that has a sort of repeated loop behavior can be modeled using some of these mathematical principles. So with that, a good example of how we can extend on the idea of electrical circuit theory to another type of circuit theory is perhaps something like the circulatory system, where the idea is you have this four-chamber heart. So this is the heart. Here's something that just splits the two sections. And in one end, we have an atrium over here. So that's just my oddly shaped atrium. And what happens is that the flow goes from the atrium to the ventricles, and then it's going to go to an artery. And in the case with this one, the artery is going to go ahead and go to the lungs. This is ultimately going to go ahead and return back to the atrium on the left side of the heart, which is then going to pump the blood into the ventricle, and which then will move the blood to the rest of the body. So this is just a typical circuit that you'll see in biology. So just to have some arrows just to go ahead and show this, the blood will move in this direction. This will go to the lungs, return back to the heart, and then go back to the rest of the body. So in fact, actually, a lot of circuit theory when it comes to hydraulics can actually be used in the context of electrical circuits. So when it comes to explaining electrical circuit theory, it's always beneficial to actually use water analogies to explain exactly why all of this works. So we're going to go ahead and do that and cover just a few basic principles of electrical circuit theory with the water analogies.